Hi, welcome back to Shouting Electronics. In this short video, we are going to show you how to go and hook up one of these or similar energy monitor into your distribution board to monitor and show you electricity usage. Okay, so with these energy monitors that you get the transmitter, you get 1 or 2 or 3 current transformers that's going to clip around one of the main lines in your DB or the line of whichever circuit you want to monitor, and then you get the little display that gives you usages and things like that. Now between the transmitter and the display, it uses a wireless communication, so I'm hoping eventually I'll be able to decipher that communication, then I don't need a display. It can automatically go into my Linux server or whatever, or an Arduino or anything, and basically graph and do whatever I want with the data. Okay, so let's go. Firstly, got to put batteries in, because the safest way of doing this current monitoring is not picking up power from the DB. So I just got batteries for the transmitter, batteries for the receiver. Current transformer clips non-invasively. Say this is the live wire in your DB. This goes in there, clip, latches, and there we go. Okay, so transmitter, and we've also got 3 different channels in case your neighbors have a similar thing, and then you're going to get confused readings. So 3 AA batteries. We'll leave this on channel 2. Or should we go channel 1? Let's go channel 1. And then drop the batteries on my lap. Plug the current transformer in. Oh, there, I saw a red flash. Okay, so that's good. So leave that plugged in. Let's go and put 3 batteries into the receiver. Over there. And the receiver's blank, so let's boom. Guess what? We get to do a quick take it apart and see what's happened to the reset button. This is our back of our battery bank. We've got corrosion there which caused that wire to come off. Our wires have come off. And it's a DC jack board, and the wires are just busy flapping in the breeze. We've got positive, middle, and negative. That doesn't help much. So let's try. Okay, so sets. Okay, there's all price rates, peaks, alarms, country, South Africa, currency is rand, voltage. Good question. Make sure the multimeter is not set onto currents when we do something like this. Okay. Look at that, we're running 245. Okay. So close to 250. So let's say 240. Unit other. channel. We want to change it to channel 1. Okay, so now we should be able to go and put the transmitter in the DB. Okay, so we switch off the main switch and the UPS starts beeping. Refer to user manual. Okay, manual. Of course, you shouldn't do this unless you're confident about what you are doing, because even though I switch on power, there's still power onto this wire that I'm clamping onto. Okay, so there I've put the current clamp on, and we're not going to switch on power yet until we have this connected to the transmitter. And your phone's going flat. Okay, so we're sticking the transmitter up over here. Putting the current transformer in. The reason we do not put power on and the current transformer is not connected to the load is if it doesn't have a resistor in it, the voltage can shoot up high and damage the insulation in the windings on the current transformer. That's why whenever you work with current transformers, make sure you switch off your supply so you don't have any current going through them until they got their load. Okay, so let's switch this back on now. Okay, so now I've got the energy monitor up in the house's distribution board, which is fed from the meter out in the street. So I'm going to go outside to the street now, take a measurement of, or take a reading of that meter and the reading at the same time of the energy monitor, just so we can see how they compare. The meter out in the street is billing rated. Basically it's calibrated and things like that, and it's measuring the voltage and the currents to work out the power. It is an old analog meter, so it's not all the new fancy digital ones. This, as you saw, we just put in what voltage we expect, or round about the same, so there will be a slight discrepancy because this thing's not measuring to power, it's measuring the current and making an approximation on the power. Let's go out to the street now. Which they kindly left unlocked. Okay, so 259.33.5, because you see that's a white mark there, a white digit, so that is a point. That's 1/10 of a kilowatt hour. So if 259.33 is equivalent to 0.454 kilowatt hours, and we're going to be doing a comparison based on that just to see how accurate or how closely they're tracking to each other. Okay, so let's close it now. And we put the lock, and we won't lock it because it's always nice if I want to switch off so I don't shock myself inside. Okay, so now we've got our reading from our utility grade billing meter and from our portable or our little home consumption use meter. And we can compare it, and then I also want to see if I can sniff the traffic and try decode what it actually sends. Okay, so here I've got my NESDR smart dongle and GQRX running on my Ubuntu laptop. And if we look over there, we're getting a signal pulsing every now and then at 434 roundabout megahertz. And there we go, we're getting pulses. So this is definitely coming from that transmitter at around about 433.985 megahertz. Okay, so the next thing will be to try and figure out how to decode this signal, but that will fall into another video. So if you like this video, please give it a thumbs up, subscribe to the channel and click the little bell icon to be notified anytime we upload new videos. Thanks for watching.